How is an atom's mass number calculated? Imagine you are building a tiny universe inside a speck of matter. Every atom is like a mini solar system with particles orbiting a core. But what makes each atom unique? It's the number of particles in its nucleus. Today, we're going to find out how scientists figure out an atom's mass number. The mass number is simply the total count of protons and neutrons in an atom's nucleus. Protons are positively charged particles, and neutrons have no charge at all. Electrons orbit the nucleus but are so small that their mass doesn't really affect the atom's total weight. So, when we talk about the mass number, we only count protons and neutrons. Historically, scientists like John Dalton in the early 1800s started to understand atoms as tiny, indivisible units. They assigned relative weights to these particles based on hydrogen, which was the lightest element. Later, scientists discovered that atoms of the same element can have different numbers of neutrons. These different versions are called isotopes. That's why atomic masses are often not whole numbers. They are averages based on isotope abundance. However, the mass number itself is always a whole number. It's a simple count of the particles in the nucleus. For example, the isotope carbon-12 has 6 protons and 6 neutrons, so its mass number is 12. If you look at another isotope, carbon-14, it has 6 protons but 8 neutrons, giving it a mass number of 14. Knowing the mass number helps scientists identify isotopes and understand nuclear properties. It's also important in nuclear reactions and radioactive decay. When atoms undergo changes, their mass number can stay the same or change, depending on the process. In nuclear physics, the mass number is used to calculate atomic mass units. One atomic mass unit is defined as 1/12 of the mass of a carbon-12 atom. This helps us compare the weights of different atoms easily. So, to sum it up, an atom's mass number is just the total number of protons and neutrons in its nucleus. It's a straightforward way to measure the atom's nuclear mass and helps us understand the different forms of elements. This simple idea has played a big role in the development of atomic theory and our understanding of matter itself.